Alrighty, happy Wednesday. So I dropped this link in my Discord. I'd like to throw interesting stuff there. This one seemed neat. So this is Python training for JP Morgan business analysts and traders and some clients. I don't really exactly know what that means. You probably have to give them lots of money or have lots of money on account with them for them to spend time with you. But looks at numerical computing, data visualization. So we get slightly into visualization near the end, which is one of my favorite things to do. We just don't have lots of time for it, unfortunately. But there's other courses you'll do visualization in. It's not a complete course in computer science, but how you can do cool things, even if you don't have a programming background, or maybe you're a semester into programming. So they did it in person. This is slightly old, looks like a couple years, depending on which one they've updated here. And this uses Jupyter and the financial data from IEX Cloud. This is really cool. I used to use them, but then they made it harder to use and changed how much data they gave you for free. But you can get cool market data from them for free if you sign up and go through a couple steps. So if you're into market data, that's one cool place here. And then again, it uses Jupyter notebooks, or you can do this online cloud instance, which is really cool. So using Binder, it will show all these different Jupyter notebooks. You can install Jupyter locally to do Python things and put together these notebooks. So everything in there, I have to go back. I'll leave it open here. Yeah, so any of these notebooks here is where all that interesting code was. So this Binder lets you give like a nice little web interface for it, which is fun. So here's some quick little basics here, but as financial data might be more interesting. Are they going to run? Is it thinking about it? Is it still thinking about it? Where'd it go? We had data in here. All right, let's try a different one then. Okay, this one has some stuff in it. All right, so it's showing you this is the code it's running here to get some data out and do some cool things here. So it shows you little bits of code at a time, and then essentially the output of them kind of in line, which is kind of a fun way to follow it here. Yeah.
Can we also, for data science projects, can you get like data sets on Kaggle?
Oh yeah, there's tons of places to get your data sets from. Yeah, lots of cool things. So Kaggle's got a huge collection of them. There's even like data.gov has all sorts of government data sets. Tons of things if you want to start playing and analyzing data. So again, some of these things don't really necessarily make a lot of sense here. Like what is PD, read HTML, stir, table 0, head 20. We can sort of piece some of this out here as we go, right? So this head 20 means I only want the first 20 rows, the header, the first 20 from the start here. And then, this must be whatever the 0th index is here. And then the 0th table here, we're converting to string, getting out of HTML, something. So there's probably find some sort of data here from Wikipedia, right? This is the list of sovereign states, Wikipedia here. And then going and get some information from them. And you can do interesting things depending on what we're doing. So this DT from URL, it's actually not a terrible name here. This is data frame. We haven't gotten into pandas yet. You'll use that in other data science libraries, but it's something you do with that here. So it turns it into a data frame, which is something easy you can work with here, which is nice. So just some cool stuff if you want to play around with it and see what they have. I thought they had, what was wrong with their financial data? Because that was much more interesting. Advanced plotting. So when we get to matplotlib is one of the coolest libraries out there. So any sort of graph you want to get into, basically you can do in Python. And it's matplotlib. Just Google it. They got their own site here, matplotlib.org. Okay, that's what it is. And they've got all sorts of cool things. You can try it on Binder. That's that website we were just on using theirs, or you can just look at some of their examples here. Like, hey, I want to do scatter plots or line charts or like any sort of charting you want to do, they probably have one for you. And this is tons of cool examples. You can download them and play with them here, just in Python code or in Jupyter notebooks. Lots of cool stuff here, just to get you excited for what's in the future, right? I know it's a bit rough starting, and everything we do, we type into the console box, and we just see a bunch of black text. That's kind of boring. But you do get into more interesting stuff eventually, right? We're just kind of trying to start off a little slow as we go. Does that make sense? All right, cool. So we've got the rest of Chapter 8 here to work on dictionaries. Not so many chapters or sections here like we did with lists. We kind of blitzed through the list ones. We've done some list stuff before. We did more with lists, kind of focused on two-dimensional lists, right? A list within a list. And then we worked on Connect 4. Looks like a lot of people had some problems with that. We can talk about a little bit of Connect 4 if you want. I don't want to do the whole thing, but maybe one of the diagonals might be a good exercise to work through just to practice with that. And then we'll look at dictionaries and dictionary nesting, or a dictionary of dictionaries. So the plan for next week, right, because we don't have new content, we just have the midterm review. My plan is to do a lab on 1028 on dictionaries. So that way we'll get more practice with dictionaries. We'll do something with two-dimensional dictionaries, or a dictionary with dictionaries of dictionaries, like a nested dictionary for lab on 1028. So we'll do the midterm review for lecture time. We'll go over the midterm. I'll post that later today. That way you have a chance to look at it and see it, and you can come on Monday. Like, if I just show it to you and then answer all the questions right away and you haven't had a chance to try it, that's not going to be very helpful. So the goal is I'll give you the practice midterm. You can actually go and try it all, and then I'll show you all the solutions as we go through on 1028. Shouldn't take us too much time on 1028 to get through it here. It's not super long. Let me go, yeah, I can go grab that. Or I think I can without showing anything. I just don't want to show the wrong thing on my screen. Let's see, I think I can do it. So let's find fall, go to quizzes, midterm, yeah, here we go. So I think I can just take the midterm here, right? Preview, okay, cool. So I'll print it out as a PDF later in a second for you. It's got to expand all these because they're obnoxious. Okay, I think that loaded all. So now let me print as a PDF. Make sure we get it all here. So there's one. They come out really long because I used like just big essay boxes every time. So sorry, it's rather tedious here, but it's not so bad. And let me put this to my desktop. So yes, one practice midterm. All right, we'll come back to our course and I'll drop that in there for you. All right, so practice midterm. You get a free point just for acknowledging you'll work with the policy. You don't cheat, right? It's open book, open notes, open internet. You cite your source. You can't give me an entire quoted answer, right? If it wouldn't fly in an English class, it won't fly here, right? And I have to fill out a bunch of paperwork, report you to the, I think it's the Academic Conduct Committee now, not the deans, or they're like, I forget how all that works. They send me an update every time, and it's a lot of things to read. Do you read all your emails? Am I the only one who skips some of them? No, you read them all, or you skip some and I feel bad? All right, I don't know. They send like a weekly update every week. There's just a bunch of stuff to read. Anyway, so just agree to it. You get a point. You put your name down, and then this goes in my whole packet of stuff when I have to fail someone inevitably. Like I've not had one semester without someone cheating in 12 years, and blows my mind. Like, it's not hard to not cheat. I promise. Just try. It's open book, open notes, right? Just try. It's okay. Anyway, so then quiz style questions. These are true-false questions, but if they're false, you have to correct the statement. Right? So variable names can be anything you want them to be as long as they only use letters, numbers, and the underscore character. If that's true, you just put true. If it's false, you correct the statement. And in the spirit of this, you don't just say they can't be anything, right? Like, sure, that's technically true, but like, come on, give me, like, what does that really mean here? Okay. So is this one true or false? We'll spend more time on it Monday, but just for a practice. Is this one true or false?
I mean, it can't match with like certain things, right? Like it can't be like a function or something that's already in Python.
Yeah, so technically false, right? You can't just be anything here, right? It will get upset with you if you try and use the reserved words here. So it's false. They can be almost anything except for the reserved words. Like, that would be a better way to correct the statement to make it true. Okay, and then on and on and on, just more of those questions. So the 15 quiz style questions that are pretty quick. Again, the goal is those are about a minute a piece or so. and then 3 long answer questions. These ask you to write like a paragraph of code, right? Not a whole project, just a small little bit here. So this one says, write a program that asks the user to enter 10 scores from 0 to 100. Ensure the values entered are from 0 to 100, inclusive of both ends. For every valid value entered, count how many values are greater than 80. Print the number of values greater than 80 at the end. So we've got a little loop asking them to do something, another loop to validate, and then we're counting ones that match a certain thing here and just tell them, okay, here's how many people got 80 or better, right? That makes sense? So again, the goal was this. This is like maybe 10 minutes to do. If it takes you double that and takes you 20 minutes, you still have plenty of time. Not that it's timed, but if I were to time this, right? I'm not giving you more work just because it's a take-home test, okay? The next one, write a function steps to 1 in 3x plus 1. This one sounds, it's a fun little math thing here, that accepts an integer value. Count the number of steps it takes to get to the value 1 by following the rules below. If the number's odd, multiply it by 3, then add 1. If the number's even, divide by 2. We're just going to count how many steps it takes following that rule to get down to 1. So if I pass it 5, it's odd, so multiplies by 3, add 1, that's 16. 16's even, divide by 2, it's 8. Divide by 2, 4, divide by 2, divide by 2, I get down to 1. Now, this works with any number we can imagine. It's not been mathematically proven that it always works, so if you ask one of your math profs about this equation, there's a whole fun story behind it and things like that. But essentially, as far as we know, any number you give this will eventually come down to 1. We just can't prove that it actually works, because math is harder than just trying numbers out. Okay, so just count. So again, it's a loop. We do something and we're counting in our loop. 10 minutes or so. And then the last one here, write a program that allows a user to create and manage shopping lists for various stores. Create a dictionary that has a key of the store's name and associate a list with the value. So this is a dictionary with the associated values of lists. So lists are nested in a dictionary. This is kind of what we're getting into this week. Allows the user to view items for a given store. Oh, hey, what's on my list for Meijer? And I'll spit out everything in the list. Here's the list associated with the key Meijer. I'll spit it out. All right, what's on my list for Costco? All right, here's all the items I'm going to spit out that are associated with the key of Costco. It's just a list, right? Okay, what do I want from GameStop? Here's the list of things that I have associated with that store, right? If they don't have a list for that store, ask them if they want to add something, right? Oh, you don't have a list yet for, I don't know, Kroger. What do you want to add, right? Right, and then we can add more items as well, right? Do you want to, here's your current list, do you want to add more things? We don't even need to do any special checking, just let them throw whatever they want on the list here. So you could have bananas 7 times on your list for Meijer. Nobody cares. That's, we'll just throw it on the list, okay? We just keep on looping until they're done. So do you have more things to add, yes or no? Or do you want to look at more lists, yes or no? Whatever we want to ask here, right? That part makes sense? So that's it. So just the 3, like again, maybe a paragraph. This should only be like 10 lines of code. This is not super long here to solve this one. So again, I'll go over these on Monday for you. I'll go over answers for them. If you got questions, we can tackle those. But essentially, this one's a little loop that does some checking. You'll have another question about loops that does some checking. This one here is another loop that does something. We'll do another loop that does something here. This one's with lists and dictionaries. We'll do another question with lists and dictionaries. Okay? And that should get us through all of the content we've looked at, right? Because we don't get to forget any of the earlier stuff here, right? We are going to do branching all the time. We're going to use loops all the time. I'm not super particular about using functions right now. That's okay. You don't need to do the function on the midterm. That's all right. But lists and dictionaries, okay? You feel okay so far? All right, and don't forget project 2 is also due on Monday. Oh, that's right. We got to talk about the project 2 solution. So that should fill up most of Monday then. If we got the project solution, midterm review. Okay, and then for the lab, we'll do the dictionary lab and during our lab time. All right, awesome. On to new fun stuff in dictionaries? Or do you want to talk about Connect 4 first? Yeah. Sure, yeah, no worries. Okay, so we did the tic-tac-toe example here. I can throw Connect 4 in here as well. So we make it a new project. What was this lab? Was it lab 6? I should remember. Okay, 6, good. They don't always match the chapter numbers, which is weird, but that's fine. All right, so we said we were going to have a board, and we're going to write a bunch of functions. So we'll look at like one of the diagonal matching ones, because I think that's probably a quick one to look at. And that's where a lot of the hang-up's going to be. Here, okay. Define, so do you want the diagonal ups or do you want the diagonal downs? Which one should we do? Or this way for you guys, right? Diagonal downs?
Yeah.
Sure, okay, so define did someone win? I don't know. Someone win diagonally down, given a board. Okay, so again, we need a board eventually here. So our board then will be a list, and this was 7 wide, right, by 6 tall. There's 4, 5, 6, and 7, right? So that's the first list, right, of our 2-dimensional list here. And then we do a bunch of these here as we go. So that's 1, 2, 3, 4, 5, 6. I think those should all be tabbed in one. The tabbing on this gets a little weird. It's probably okay, right? So it looks like our Connect 4 board essentially, right? So we've got indexes 0, 1, 2, 3, 4, and 5, and we've got columns 0, 1, 2, 3, 4, 5, and 6. Okay. So we said when we're checking for diagonal down, I need to get 4 in a row. So the only ones I need to check at are these top 12 up here, because to get 4 going downward, I cannot get any farther down than the 3rd row, because there aren't 4 rows if I start lower than that, right? If I start down here, there's not 4 rows. It's not going to happen, right? And I can't get any further to the right than the center because there's not 4 columns, right? So I'm going to go from row 0, row 1, and row 2, right? So we're going to say this is row index in range 3, because I want 0, 1, and 2. Right? This will give me the first 3 rows here. And then for column index in range, now this one I want 4 because I want 0, 1, 2, and 3. Right? Because it's exclusive of this here. So these are going to be my starting values here. So I'll get 0, 0, and then I'll get 0, 1, and I'll get 0, 2, and I'll get 0, 3. Right? And then this column loop is done. We go back to the row. Now it says, okay, row plus 1. Let's go row 1, row 2, or I'm sorry, row 1, column 0, row 1, column 1, row 1, column 2, row 1, column 3. Does that part make sense? So we're going to get all 12 of these starting positions. Once we're in one of those positions, now we need to check 4 values, right? So I'm going to see, is the one I'm at not blank? And then does it match this next one and the next one and the next one, right? So if my board at the row index, at the column index. And this is where it gets a little weird looking here, because we say, hey, give me the row index value out, right? Because it's really just a list. So what index do I want in the list? Well, this entire list is index 0, this entire list is index 1, this entire list is index 2. So give me either row 0, row 1, or row 2. And then within that now, I know because that's a list, I can ask for the column essentially, right? What item, what position within that list do I want? Well, that's the column. Okay, give me 0, or give me 1, give me 2, or give me 3, right? So if that one does not equal a blank, right? And now I need to check, does it match the next one? So if it's not blank and it is equal to, now to go up a row, that's plus 1, right? Or down a row, I'm sorry, right? To go down, that's plus a row, right? Because unlike Mathland, our 0, 0 is the top left. This is really confusing when you switch between math classes and programming classes, but our 0, 0 is always the top left for you. Right, row 0, column 0 is top left. We don't have an origin, so it's a little awkward, but we'll make do. Right, so does 0, 0 match whatever that is plus 1 plus 1? Right, so let's go diagonal down, or that way for you guys. Right, let's go down 1. Right, to the right one is column plus 1. Down 1 is row plus 1. So we'll say, does it match where I currently am plus 1 to where the column is plus 1? Right, if that one matches, and if it matches the next one, so that's plus 2 and plus 2, and it matches the fourth one, that's plus 3 and plus 3. Right? If all of those match, then I can return true. Yes, someone won diagonally down. That got mixed up here. I don't know what happened. Okay, right? So for any of those 12 starting positions, let's look at, is it not blank? It's an X or an O, or red, or black, or blue, or I don't know, whatever values you're giving it here, doesn't matter, right? And does it match the one diagonal down? Does it match the one diagonal 2? And does it match the one diagonal 3? Right? If that is all true, then true, somebody won. If I get through all 12 of those values here, all 12 of my starts here, and I didn't find a winner, I can say, nope, nobody has won diagonally down. I can return false. So I'm either going to get a true or false out of this, right? I'll only get true if it finds a winner. Great. If we check all of them and no one won, no, it didn't happen. So we can actually test this out, right? So we can put a winner in here and say, hey, let's call this an X, this one an X, this one an X, and this one an X. Now, it doesn't have to make sense, right? We don't have all the O's that it's on top of or anything like that. We just want to check, does it actually work here? So we're going to print, did someone win diagonally down, given the board? We should get back a true, right? Because it should find this winner diagonally down. And we get back true, right? So let's take one out here. Let's say now this one should get a false back, right? Nobody won in this case, right? Or if we put an O in here, maybe. If we get a different value in here, false. Nobody won still, right? So we can check to make sure it does what it's supposed to do for us. Does that part make sense? All right, I think the other hard part was dropping a piece. Do you want to look at that one too? Okay, sure. So we can look at drop a piece. So define drop a piece, given the board and the current player. Okay, so we have to get what column do you want to drop into, right? Because we don't ask them what row, because it will just drop down to the lowest available column, right? Starting at the bottom. Right, so let's take these out of here. And then I guess we probably also need print board, right? Just so you can print a board. That's not exactly like our tic-tac-toe one. So we'll print board, given a board. Now this one, we can just say for row and board, print the row. We don't need it to look pretty. We don't need to add dividers or anything like that. Like for tic-tac-toe, we added in the dashes and the lines to make it look pretty. This is probably fine here. So we can print out the board here. Right, so nobody won. So for drop a piece. So we have to get the column. So our column index will be an int of an input. Enter the column you want to drop a piece in. Sure. Okay. Then we need to make sure that you actually can put a piece there. Right? So the quick check is to check row 0, which is the top row. If there's not blank, then you can't drop something in that row because it's already full. Right? That's going to be an invalid move. Or if it's greater than 6, or I mean, we can do all sorts of sanity checks here too, but that'll just crash on us. So if it's not blank, we're going to ask them again. Right? So while my board at 0, right, the first row, the top row, at the column index does not equal a blank, we're going to keep on asking them, right? And maybe we just print that column is full, right? And then ask what column they want to drop a piece in or something, right? Just give them a message. That was no good here, just to make sure I get something valid here. Once I know they picked one that has a blank, I need to start from the bottom, right? So I'm going to say for, this will be my row index, in range. Now I want to go from the bottom up, right? Because I want to check the bottom row first. If I can put a piece here, good. If I can put a piece here, good. If I can put a piece here, good, right? Keep on going up. So if I want to start at the bottom, right? This is 0, 1, 2, 3, 4, 5. I want 5. So I'm going to go from 5. Now I want to get to 0, but it's not inclusive of the end. So I want to -1, and I want to step by -1. So if you don't like for loops, you could also use a while loop. Right, a while loop is pretty good too if you don't like these 4 ones here. Right, we could say row index is equal to 5 and while row index is less than, or I'm sorry, greater than or equal to 0. Right, we could do it this way, and eventually we'll just take row index plus equals 1, or I'm sorry, minus equals 1. Right, so you could do a while loop or you could do a for loop with a range. Either way is going to work for you. Whichever preference you have here is fine. Again, I think the for loop is fine, but if you like this one, let's just comment that out here. Okay, so we could do that, or we could do with our for loop here. So if my board at the row index, at the column index, is equal to blank, if it's blank, then I can put my piece here, right? So if the bottom row, row 5, for that given column is blank, great, let's put my piece in. So then I'll take this and I'll assign it the value of the current player. Then what I want to do is I can just break my for loop. Sometimes breaks come in handy, right? So break says, oh, stop the loop, you're done. Just quit. Whenever we get to this point, you're done. You don't have to do any more work, right? If you don't like breaks, we need something else to make this stop. The other thing we could do is just return as well. Like return will just stop the function when we hit a return, right? So we could just say return. break is optional. Because this will make the function stop. And I know that one of these places will be okay because I got out of this while loop. I know there was a blank somewhere here. So the first one I find, if it's not at 5, let's look at 4. If it's not at 4, let's look at 3. If it's not at 3, let's look at 2. If it's not at 2, let's look at 1, right? So that I can keep on going here. So essentially I'll just do, I don't know, I'll just say while true for a minute here. This is terrible, don't do this at home. Don't do this, just to show. So we'll say print board, given the board, and then we'll call drop piece, given the board, and X, right? We should be changing current player. You can just steal that from tic-tac-toe or whatever here. But now we should get, here's the board, and what column do you want to drop a piece in? Yeah, what column? Column 1, sure. All right, column 1. Now we have an X. Now where should we try?
Column 1 again.
Sure, column 1 again. Hey, look at that, it's stacked. Should we keep trying? Make sure let's fill it up, see if our check works here. So we should have won, but again, we didn't actually finish all of our checks and those sorts of things yet. So now if I try 1, it says that column is full. You can't do that. So our check here is working. Now if you put in something like 7, the whole program crashes, list index out of range. We'll figure out how to do that later. That's okay. But essentially, we should be able to drop it in any piece, any column we want. 0, 1, 2, 3, 4, 5, and 6. They all seem to work here, right? 1, 2, 3, 1, 2, 1. You can make pretty patterns and do whatever you want here, right? So far this seems to work. Does this make sense for this? Okay, cool. And I'll just give that a stop. So if the diagonal up, right, is the other direction, right? We're going to check those bottom 12 down here, right, going upwards. So that's minus a row, still plus a column. Same idea though. With that, we did a horizontal, right? So you look for each row, look for 4 in a row, right? But you stop at this one, right? This is the last one we're checking because there's not 4 in a row after that, right? For the verticals, again, you can stop it at row 2 because you need to make sure you have 4 rows to check as you go through each column, right? So just a lot of loop within a loop. Right? We're saying, hey, here's where my rows are going, here's where my columns are going, let's check this and plus a bunch. Make sense? Maybe not. Did I go too far? I had a lot of coffee. It's been a day. Actually, this is espresso, but that's okay. It's an Americano because that's fancy. Right? If you can't be fancy, what are you going to do? Gotta have some fun. You okay so far? Maybe? All right, I'll push this out to GitHub. We can take a look at it later. So here's lab 6 started. Give you some ideas for that. All right, and we'll go back to, let's do chapter 8 dictionaries. So that we've got 2 groups of these here. So this is dictionaries. We'll work with some dictionaries. Oops, come on. Drag it over. All right, so if we want to do something like a grade book, right, that's a dictionary. Now, it probably has your name or student ID or something in here, right, to identify who you are. I'm going to use name because that's easy. We would probably really use student ID number because that's a better unique identifier later. That's okay. So we can say, hey, gradebook, then key of Eric, and I want to associate the value of another gradebook. Because what I want to have in here is another dictionary here that now I can keep, here's my assignments or something in here, right? So in here then, I can say, hey, gradebook, key of Eric, key of project 1. And I'll associate the value of, hey, maybe I had a 95 on that one here, right? And then, hey, gradebook, key of Eric, key of project 2, maybe on this one I got a 98. And then maybe now we have a lab 1. This one maybe I got 5 points out of 10, or however we want to do this here, right? Now this is not a whole lot of information, right, to just have a given score here. This gets a little bit messy, right? So it might be nice to have like your score in total points or something like that. Right? So we would need more than one value associated with this here. We could either do another dictionary with a dictionary of dictionaries of dictionaries, or just make it a list and say, hey, no, the first one is going to be your score, the second one will be your total points out of. So it might be easier to make this like a list and say, hey, this was 95 out of 100. And this was 98 out of 100. And this one was maybe 5 out of 10. Right? So we'll have a dictionary with an associated value of another dictionary. So then I have a key and another associated value of here's your score and total points, score and total points, score and total points. So we'll just have to know that the order of this matters here, right? So then I can say for student in my gradebook, right, this will give me each key out here, right? This loops through keys, okay? Then I can say for, I don't know what, assignment in the student. Seems a little silly here, but that's okay, right? But this is just a key. I can't loop through student. I would actually get like each letter out at a time if I tried to do this loop here, right? So if I were to print assignment here, so just because I call it assignment doesn't really mean it's the assignment here, right? I'm going to get Eric out here, right? Because the student is the key. So I want the gradebook key of the student here. Now I'll get the next dictionary out, which is the dictionary here, right? That's associated with Eric. Now I'll get each key, again, so this is the key here, is the assignment name. So now I'm going to get project 1, project 2, lab 1. Right? Because that's the key of the gradebook associated to the value Eric. Right? Because we're a dictionary of dictionaries. It gets a little weird, right? So we kind of have to spend a little bit of time thinking through what we're actually getting here when we get these things out. So then what I'd want to do is, so I'm going to have, say, like total score. So for each student, then I'll have a total points is 0, and then points earned is 0 to start. So I don't need to print the assignment. What I want to do is I want to take my total points plus equals my gradebook key of student, key of the assignment. Then the total points then is the second value. Oh, that gets messy. So the second value is index 1, and my points earned is my gradebook key of the student, key of the assignment, index is 0. Oops, too many plus equals there. Right? The first thing is how many points I earned. The second thing is how many points total it was. I'm going to go through and add that up for every assignment. Right? So I can just print my gradebook. So I'm going to print, let's do a formatted string here. So I want the name of the assignment, right? That's the key here, is the name of the assignment. And then I want that value here. So I'm going to print my gradebook key of student. Oops, I need my curly brace here. Key of the assignment to get the values associated here. And I'm going to add up all those points here. And then when I'm done with every assignment, right, in here, then I can print my formatted string for the student's name. So it's the student. And then their score then will be their points earned divided by the total points. Right? And we'll throw a little percentage sign on here to make it look pretty. Right? Oops, we've got to multiply that by 100 then, right? And then we probably want that as a formatted string, like what, 0.2f, right, to get 2 decimal places. There we go. This looks like nonsense, and it really is. When you start putting dictionaries inside of dictionaries inside of it starts to hurt your head. So it takes a lot of puzzling through to think what each level is as we go, right? And that's just going to just print it out and see what you get here, right? And we have to spend a little time thinking through it here. But the assignment is the name, right? That's the key in the dictionary that's associated with the given student here, right? The value associated with the student is another dictionary. It's keys, right? So this is keys, the dictionary associated with the student key, right? Here's the assignment name, and then this is the actual value associated with it. So that's the list associated. So the first thing was how many points that we earned, and the next thing was how many points total. Right? So we can see, hey, pretty quick, down to a 94%. Actually, a lot lower than I thought. I thought that would have been a lot higher than a 94%. Did I do that wrong? So it's 95 and 98 on the 100 points? Is that really? So that's 210? No, so what, 95 plus 98 plus 5 divided by 210? Thank you, order of operations. Come on, calculator. Don't be the fancy one. Go to the standard one. There we go. 95 plus 98 plus 5 divided by 210. There we go. It is a 94%. I really thought it would have been higher with a 98 and a 95, like with a 1 bad lab score. That's surprising. All right, anyway. So working through the dictionary, right? The key of gets me another dictionary. Key of gets me the value associated with that one, which is the list then. So that's the first item and the second item. This first item in the list associated with the assignment. Right, and this is the next one, and so on. Maybe I should put that up above one. No, it's the wrong enter key. We'll put it there. Is that helpful? Like to drop a little note in what this one was here, to work through it. So if I wanted to add more, right? So just the setting it up here is nice to play with, but what we really want is like for the user to be able to work with this. Hey, what student do you want to find? Right, so we can say, okay, get a student is an input of enter a student to add to the gradebook. Okay, and I take my gradebook, key of that student, right? Well, really I can see, if the student is in the gradebook first, right? Is the key present? If it is, then I don't really need to do anything. So if it's not in, then I'll assign a new dictionary. Right? If it is in, right, else maybe then I just print, here's what's currently there. Right? So if I give it Eric, I'll get out, here's the value associated with Eric. Well, that's a dictionary, right? Here's the dictionary associated with the value Eric. If I give it a student that's not in the list here, then like we'll give it Jeb. Oh, well, we didn't really do anything then, so I guess we should ask. So we'll get a assignment equals an input of enter an assignment to add for, let's go with their student name, student, and make this a formatted string. Assignment to add for the student. And then once I add the assignment, I'll take my gradebook, key of the student, right? That is a dictionary itself, so then I can take the key of the assignment then and associate it with a list. Right? So I know there's a dictionary associated with the student because I just added it. So I'm going to add a new key of the assignment. The value I want to associate with that is a list, and I'll get two values. So I'll get the points earned, then will be an int of an input of enter the points earned, and then I'll get a total points is an int of an input, enter the total points possible. And then I can take my gradebook, key of the student, key of the assignment, and I can call append because that is a list. Right? The value here that I get associated with this assignment is a list. I just added it here. So I'm going to append the points earned, and then I can append the points possible, or total points. Maybe points possible is better, but whatever we want to call it here is fine, right? And I guess when I'm done, I can just print it out anyway, right? So when I'm done with this, I'll just print all the information I just added so we can see it here. All right, so we'll go add Jeb. Okay, what assignment? Let's do project 1. Let's say he got 75 out of 100 here. Now I see, hey, here's the dictionary associated with the student Jeb. Right? And we could go through make another loop. Hey, do you want to keep adding more assignments? As long as you didn't enter done, right, we'll go through and do that, right? So maybe while assignment name is not none, so I can say assignment equals nothing, and while assignment does not equal done, right? We can keep on adding things here. So maybe actually we'll do this one first. I'll put this up top here. And to the student assignment name, we'll assume they're going to add 1, right? Because why else would they add a student to the gradebook? And then at the end of the loop, we'll ask one more time to add another assignment. An assignment to add for the student or done. Okay, so if they enter done, we stop asking. If they don't enter done, we'll say, okay, let's add another list here for that given assignment. Get the scores, add it in, get the next assignment. So this way I can enter as many assignments as I want here. So let's add Jeb, we'll say project 1, he got 75 out of 100. We want done, no, let's do project 2. Project 2, he got, let's do 85 out of 100. Okay, now let's call done, yeah.
So when you do gradebook student, if let's say if you entered Eric, because that's like a branch you already made, is that going to create a new branch, or is that going to be an existing like branch? Because you already have values entered for Eric.
Yeah, so if we wanted to like add more stuff for Eric, we could do an else here. So we're saying if the student's not in the gradebook, let's start off from fresh here. If they are in the gradebook, we could do something different. You want to like add more assignments for Eric?
I was just asking if it's going to like create a new error.
No, because we just totally skip over. So we said if I find that key, nothing happens. We don't do anything. So it would probably make sense to let you do something, and that's what actually we're going to do for our lab is we'll finish out this gradebook assignment thing here, where if I did find the student, now here's everything I have, do you want to add more? Right? And do a couple interesting things with that. So this is just, if they don't exist, if they're not in here, I want to go do something, right? Because you can't have the same key twice. So either you're going to overwrite, or you can go and add to it. Right? I could delete everything I had and add a fresh, brand new Eric if I wanted, like an empty dictionary for Eric. This was just kind of working through how I would add stuff to it. This is doing it by hand. This is doing it with inputs. Right? Here's the student I named. Here's the assignment that I named, using all my variables here. Does that make sense? Okay, cool. So we should be able to get them all. Oh, I was supposed to finish that here with done. I forgot. And now maybe let's take all of this here and get their scores. How about we turn that into a function? Let's do that. So let's loop through all of our keys. Let's cut all that out and make it a function here. So we'll define print scores for a gradebook. And we'll do all those things here. So first, the student in the gradebook. We'll go through and total it, print out the student. So when we're done, we got Eric hard-coded. We'll add another student here. And then we're done, we'll call print scores, given the gradebook. Right. So if I just do Eric, it's already in there. I just get the score out. Nothing happens, right? Because we said, hey, I don't want to add a duplicate. It'd be nice to let me add more things, but we can go back to that later. So we'll add Jeb. We'll say project 1 was 75 out of 100, and we'll do project 2 was like 85 out of 100, and then we'll do lab 1 was 10 out of 10, and then we'll say done. So now when that's over, right, we go and print our score. So here was Eric hard-coded. Here was Jeb that we added everything by input. Right? Now they didn't have to match. Right? We could have given it, test 1, test 2, test 3, whatever we wanted here. Right? Whatever we enter, it'll let me put in points and points and go from there. Now, as you can imagine, this is not very useful because it doesn't save the information anywhere. And every time I hit run, I have to run it again. Right? So just looking forward here, we eventually get to working with files. So you can actually save a file to your computer and read and write from that file. So when I'm done working with my program, I could save all that information off, and the next time I run it, I could read all that information in to pick up where I left off. Right? Everything we've done with our program so far only exists while it's running. And as soon as it stops, we've lost everything because we don't have a place to put it. So once we get to files, looking ahead here, now we'll have a place to put it locally on my computer. That's when it becomes much more interesting because I can work off of, okay, here's what I had from before. Or someone can give me a file and I can process it, or I can work with a bunch of information. So this greatly expands what we can do with our programs once we can start reading and writing from files. It gets to be a whole lot more interesting and more exciting here. And then looking at like some of the cool stuff it did here, you can go and get data from the internet, right? And they go, here's the web API. It probably timed out or something. So you can go get information from the internet here. What's going on here? Can't find, I don't know, let's go back really far. Okay, that's fine. But there's a way you can go, okay, there we go. I must launch out a new one every time. That's interesting. I've not done a lot of work with Binder before. I like stuff that's local as much as I love cloud tools. It seems a little bit obnoxious, even though it's really neat. mybinder.org, that's cool. Notebooks, here's the web API one. So this can go and get information from CoinDesk. Hey, let's go get some information about cryptocurrency. So I can go and get information using this requests library to go get information from the web. This is super cool. So I can get current information about closing costs, closing prices of things here. So this one's a little bit old here, but that's fine. So we can get information out. so this is web APIs, application programming interfaces. And programs talk to each other, usually over what we call an API. So we know how to talk to each other. So I can go get information from somewhere. It doesn't have to be local on my computer. Files are cool and all, but most information out there someone else has. We're not going to have it all locally here. So this is how we get information from the cloud, right? Someone else's computer somewhere, right? Using APIs. This is super cool. Yeah.
So this is a question, but this API, does it have to do something with this computer or
With what?
assembly?
So you can write APIs in like anything you want to. So these are all, we're going to interact with it in Python. I have no idea what they wrote their API in. I just know if I ask for some information here, hey, I want the start and the end, right? Here's the start, here's the end, I want closing prices. It will go give me that data back, right? It's like a contract essentially. Like a lot like our functions are, if I call a function like .append, I know it'll just add to the end of the list. I don't know how Python does it behind the scenes. I just know it does what it advertises. That's what an API is. Right? It advertises some feature that you can use. If you give it this thing, it gives you something back. Works the exact same way. This just happens to be a web API. Right? We do it over the web. All right. Awesome. So hopefully this gets you excited for all the cool things and you're not depressed like there's a whole bunch of stuff I haven't learned yet. Like hopefully that's the, look at all this cool stuff I haven't learned yet, not the crap, there's a bunch more stuff. Because you can do a lot of cool things with Python. We're just kind of scratching the surface here as we go. So I'll see you folks Monday for midterm review. And then we'll go over the project as well. Let me know if we got questions about the project. And then we'll do our lab on dictionaries. Okay? All right, thanks folks. Sorry again to be late.